All right, so we are going to be looking at number 4 in our workbook. For the area of regular polygons, we're working with an octagon here. An octagon has 8 sides. I just redrew it on my paper and added a center. So since an octagon has 8 sides, we are going to pretend that it is inscribed in a circle where the circle touches all of the points, the vertices of our regular octagon. So they gave us the length of one side. Since it's regular, we know that all sides are equal. So this is 15, this is 15, and so on and so forth. So we can already do the perimeter. So the perimeter is going to be 15 times 8 because we have 8 sides. So if we use our calculator, 15 times 8 is going to be 120. So our perimeter is 120 inches. Our unit, we are working in inches for this problem. So we're halfway there. Remember, to find the area, we are doing half of the apothem times the perimeter. So we already have the perimeter, so we've got one piece that we're missing. Now the other thing that we need is the apothem. So the apothem is from the center, our imaginary line that we draw, that is a perpendicular bisector. And what is it bisecting? Well, remember, we have to draw our triangles. So from each vertex to the center, we are going to make a bunch of triangles. How many? 8, because there's 8 sides in our polygon. So now we have this perpendicular bisector. Well, we need some more information to be able to determine the height here, the height of this triangle, the apothem. We either need another leg of this triangle, or we need an angle. The angle is pretty easy to find because all of these are central angles. Since it's a central angle, we know that it is equal to the arc measure. 360 degrees makes a full circle, and we have how many sides? 8. So we have 8 different arcs of our circle. So 360 divided by 8 is 45. Is that right? Double check. Yes, it is correct. So what that tells us is that the measurement of each arc from point to point of our polygon is 45 degrees. And if the arc is 45 degrees, then the measure of this angle is 45 degrees. So I'm going to take this little triangle here that I've drawn and I'm going to blow it up so we can see what we're working with. So this whole thing is 15 inches. And we just found out that this whole angle is 45 degrees, but we don't want 45 degrees. We only want half of that because this is a perpendicular bisector. So 45 divided by 2 is, half of this would be 22.5. So 22.5 is the measure of this little half angle right here. So this is 22.5. Now we have a side and an angle. So we're going to work with just this half of the triangle. So now we're going from here to here. So half of 15, because again, this is a perpendicular bisector. Bisector means cut in half, the angle and the side. Half of 15 is 7.5 inches. Now we have one side and an angle. If we have one side and an angle, we have to use our trigonometric functions in order to find the side of this triangle. So we're going to be working with this angle, 22.5. Now we have to determine if we're going to use sine, cosine, or tangent. So we're looking for the height. That's what we need. So we're going to call that x. So x is right next to our angle. That means it's adjacent. So we have adjacent and we have across or opposite, adjacent and opposite. SOHCAHTOA, that's tangent. So we're going to be doing the tangent of 22.5, and it equals opposite over adjacent. So 7.5 over x. Now we have to solve this equation for x. We can't have x in the denominator, so we need to bring it out. In order to bring it out, we're going to multiply both sides by x, so they cancel. We still have to get x by itself, so now we need to divide both sides by the tangent of 22.5. And if we use our calculator, ooh, what happened? So we have 7.5 divided by so we're going to get approximately 18.1. That is our height. So what we just found is the apothem. That goes into our formula. So now we have the perimeter and we have the apothem. So plugging it back into our original formula, we have the area equals 1/2 times the apothem times the perimeter. When we plug in our numbers, our apothem is approximately 18.1 times our perimeter, which is exactly 120. So to make my answer nice and accurate, I'm going to leave this big number in my calculator. So instead of rounding it and starting all over, I'm going to leave it in my calculator, multiply that by 120, and then multiply that by 1/2. So the area of our polygon, our octagon, is going to be 1086.4 approximately, and we are working in inches, and its area, so it is squared. Ta-da!